For this problem, we want to factor, taking a look at our polynomial that is in standard form, so I can go through and see if we have a greatest common factor. Our numbers don't have anything in common, but we do have an x in all of the terms, and the lowest power of x is an x squared. So there is an x squared that is in common with all of these terms. And then once you factor out your greatest common factor, count the terms in the parentheses. I see this time that we have 4. So I'm going to factor by grouping. When I go through and factor by grouping, I do need to remember we do have that x squared out there in front. You can bring that down and put that in front and keep it there in each step, or just remember it's supposed to be there and then put it in at the end. Just to keep things a little cleaner, I'm going to leave that off for right now. Looking at this first two terms, our numbers don't have anything in common, but we do have an x cubed in common with both of those terms. Looking at the last two terms, we have an 8 in common. I could factor out a positive or a negative 8. I'm going to choose a positive because the first term in the last group does start with an 8. Factoring by grouping did work. I do get matched parentheses. So one of my factors is going to be that matched set, and then the other is what we factored in front, which is an x cubed plus 8. And then remember, we do have that x squared out there in front. From there, we should check and see if this factors some more. So looking at what's in the parentheses, I want to see if this factors at all, and it does. This is a difference of squares pattern. We have two terms with subtraction, and both of those are perfect squares. So we have an x squared in front, and then using our difference of squares pattern, I'll slide that over a little bit, give me a little more room. So using that difference of squares pattern, the reason 25x squared is a perfect square is because it's a 5x times another 5x. And 4 is a perfect square because it's 2 times 2. And the difference of squares pattern does say we need alternating signs. So one would have to be a 5x plus 2, the other a 5x minus 2. I also want to see if this binomial factors. And looking at it, it is two terms with addition, so the only option is sum of cubes. And both of these are perfect cubes. The x cubed is x times x times x. The 8 is 2 times 2 times 2. So they are both perfect cubes, and we do have a sum of cubes pattern. That factors into a binomial times a trinomial. For your binomial, you take one of each one of these things. We have a group of x's, we have a group of 2's, so I need an x and a 2. I'll come back at the end and fill in the plus or minus that goes there. The trinomial here, I just want to pair these 6 values up from left to right. So the first pair is x times x, the second pair is x times 2, and the last pair is 2 times 2. That gives me 3 terms that go in the parentheses here. And then, to get the pluses and minuses in between, we're going to use that acronym SOAP to do that. S stands for same. We had an addition originally, so the same symbol would be addition. O stands for opposite, so that's subtraction, and then always positive for the last. S-O-A-P. We want to check and see if these factor anymore. This does not fit any of our patterns, this 5x plus 2, neither does the 5x minus 2, and same with the x plus 2. For this one, we'd want to check and see if the add multiply method would work, but there are no numbers that add to be -2 and multiply to be 4, so this is our final answer. 54 minus 2x cubed is our next problem. First step, well, we'd like to see what's in common, but before we can, we do want this in standard form, and right now this is not. So we're going to rearrange these terms a little bit, put this into standard form. Then from there, we should be able to go through and do our steps. I want to see if there is a greatest common factor, and there is. It's 2. Usually we only factor out positive 2's, because so often our greatest common factor is positive because this first term is positive. But this time it's a negative 2, so I actually do want to factor a negative greatest common factor out of those 2 terms. So when you're going through and doing a greatest common factor, even as your first step, most of the time it'll be positive, but if your leading term, once it's in standard form, is negative, you want to pull out a negative greatest common factor. When you pull that negative 2 out, then we want to see if what's in the parentheses, they're factors. There's 2 terms there with subtraction, so I should check and see if it's a difference of cubes or difference of squares pattern, and this one is cubes. So that's x times x times x and 3 times 3 times 3 if I go through and kind of break that down into their perfect, or into their cube roots. So again, binomial and a trinomial. I have a group of x's and a group of 3's. When I pair these up from left to right, we have an x times x, an x times 3, and a 3 times 3. X times x gives us x squared, x times 3 gives us 3x, and 3 times 3 is 9. And then using that SOAP pattern, our original here was a subtraction, so same is subtraction. Opposite, and then always positive. I want to check and see if those factor some more, but they do not. So that would be our final answer for that problem.